in this session, we'll look into the keepers and store declaration. So basically, keepers are where the actual logic of the NFT module is written. So before that, we'll just make sure our understanding regarding KV stores are clear. So what are KV stores? So in Cosmos SDK, KV stores, or we generally say key value pair stores, are fundamental concepts used to store and retrieve data within an application. A KV store is basically a simple database that maps keys and values, so allowing developers to persistently store and retrieve information associated with specific keys. So then we'll look into the use case of it. So the use case of KV store in Cosmos SDK. So first is state storage. So KV stores are commonly used to store the state of the application. For example, in a decentralized finance, a DeFi application, a KV store can be used to store user account balances, transaction history, or any other relevant information. Second is configuration storage. KV stores can be used to store configuration parameters and settings for an application. So this will include values such as network parameter, contract addresses, fee structure, or any dynamic settings that needs to be modified over time. So next is metadata storage. KV stores are also useful for storing metadata associated with specific entities in an application. This include information about tokens, NFTs, user validators, or any other entity that required additional information beyond what is stored in the blockchain consensus state. Another is caching. KV store is also used as a caching layer to improve the performance of the application. Frequently accessed data can be stored in KV store to reduce the need for expensive computations and queries. So that will result in faster response times and improved user experience. Next is indexing. KV stores can be utilized to create indexes that facilitates efficient querying of specific data. For example, in the blockchain explorer, a KV store can be used to create indexes that enables fast searches based on transaction hashes or addresses or any other relevant data points. Then event logs are also useful. KV stores can be used to store event logs or audit trails within the application. This allows for recording and retrieval of important events or actions, like providing transparency and accountability. And yeah, it's an important note that KV stores in Cosmos SDK are designed for storing relatively small amounts of data. So typically with a range of kilobytes. So for larger data requirements, you can use other mechanisms such as IPFS or any other external database that will be more appropriate to store those data. So to summarize, KV stores in the Cosmos SDK serves as a flexible and efficient data storage solution for application built on SDK. They enable developers to persistently store and retrieve data ranging from state storage to configuration settings, metadata, caching, indexing, event logging, and thereby providing a necessary foundation for building complex and scalable blockchain applications. So this is what KV stores literally mean. Our next important concept is basically context. So we'll be using context throughout our module creation. So let's understand what are context and what does the context means. So in Cosmos SDK, context refers to the context object that is passed around during execution of various operations within the blockchain applications. So it encapsulates important information and provides utility for managing and accessing data relevant to the current execution context. So the context object typically have following components. So we'll look into it one by one. Block information. The context includes information about current block being processed, such as block height, block time, block header. And these data basically can be used for time-sensitive operations or referencing the context within the context of specific block. Basically, accessing the information about the specific block. Next is gas and fees. The context provides information about gas computation and fee management. It basically includes gas meter, which tracks the gas consumed during the execution of the transaction within the operation. So the context also includes method to deduct gas from meter and handle transaction fees. So these all things are handled by context. And third is the message signer. The context identifies the signer of the current transaction or the operation. So it includes information about account associated with signers such as addresses or public key. So this allows authentication and authorization checks in this application. So if the user is authentic or is authorized to do a particular transaction or not. So, and another one is event emitters. The context provides methods for event emitting during execution of an operation. So events are as an essential mechanism for broadcasting important information within the blockchain, such as if a transaction is successful, we'll broadcast an event, or if a contract is executed, or any other notable events that we can use to broadcast this. Another feature is the context values. See, the context allows for the storage and retrieval of key value pairs throughout the conceptual data. So these values can be set and accessed by modules or handlers throughout the execution flow. So it enables information sharing and coordination between different parts of the application. The context can be used for that. So this context object is typically passed as an argument to various functions and methods within the SDK. It allows developers to access important data and utilities, facilitating the execution of operations, state manipulation, or event that we saw earlier, and more of these things. So these are things are facilitated by context. So you can utilize context object effectively, and developers can ensure consistency, security, and proper management of resources within the blockchain application. So it enables modules to handle, to interact with the underlying blockchain or state, handle transactions, event, and control the context-aware manner. So everything can be controlled by context. To summarize, a context object in the Cosmos SDK basically represents an execution context within the blockchain application. It provides access to crucial information such as block details, gas, fees management, signers, information about event emissions, capabilities, and conceptual key value pairs, storage information. So this allows developer to build secure state event-driven application within the Cosmos ecosystem. So this is what context generally means. So where we went through the concepts of context and key value pairs, KV stores that we'll be frequently using throughout our application. So now let's hop back to our code. Previously, what we discussed, we created the protobufs using protocol buffers. Then we created transactions inside the client. You can see we created a transaction, and then we registered these transactions and wrote the type definition of it and all the checks associated with it. So here we registered the type definition and the checks associated with each and every transaction before the transaction goes to the actual state manipulation state, which is the keepers that we'll be discussing today. So let's go back to the keepers. So first of all, to write, we'll first set up the message server. So message server is the first function that is being invoked after a transaction is being called. So if a transaction is being called, first of all, the type definition will check all the checks related to that transaction, all the parameter that has been passed by the user, so that the parameters are actually valid or not. Then after these checks are passed, then it will move to the message server. So inside message server, we'll have the actual code. So let's start with the first one. First one was our creation of denom. So what I'll do, I'll just start a function name, and the function will be of type message server. So this message server, let's name it as create denom. Let's follow the convention. Create denom, and we'll pass a go context. It is go context, and go context will be of type context dot context. You can see context is being invoked here. So we discussed the importance of context here. So now we are passing it. And next thing will pass the message. Message will be of types. Types dot first is message create denom. I guess, yeah, message create denom. We got it. And what we'll do, will return the type as types will return types dot message create denom response. Yeah, we'll return it as response and throw an error if an error occurs. So yes. Next thing, what we'll do, we'll just check if the sender is valid or not. We'll check the sender. We'll check the validation for the sender is SDK dot account from bit32. Wait, let me just import an SDK here. Dot account bit32 will pass message dot sender. So we'll check it, and if an error is returned not equal to null, then we'll return first parameter will return it as nil and second will throw an error. So yeah, basic check is ready. Now we'll unwrap the context to get all those data point that we needed. Unwrap SDK context from context which is being passed here. And okay. And now we'll see, and now we'll write the actual logic associated with the create denom. So what we'll do, just go to the keeper.go. Here I'll write the logic for create denom checks. So the next function, call it create keeper. This will be a now create denom. So this function will accept an argument context. Actually, you type SDK dot context and all the parameters in state. With the class ID, we'll check for ID, we'll check for symbol. So symbol name next we had was schema, I guess. HEMA schema. This will be of type string. Next is our transaction creator will be of type SDK dot account address. Description review URI will be of type, this will be also of type string. Return an error if error is returned. So what we'll do here, just a second. Yeah. So first what we'll check for first check will be of ID. So we need to check if the ID exists or not. So for that what we need to initialize a KV store for ID. So KV stores, we just initially just make a file called denom.go, and this will be a package keeper. So this will first check if the denom has a key or not, denom exists or not. So we'll have function. This will exist as type keeper. Just name it as it has a denom or not, has denom ID. Denom ID previously exists or not. We have to pass the context again. Context will be of type SDK dot context. What we'll do, just a second, we'll import an import SDK as let me take this SDK types SDK dot context, then ID will be of type string. Yeah. First, and will return a Boolean value if it exists or not. So we'll call the store first, store, in which we call context dot kv store. We'll just call the kv store with k dot store key, and we'll return if store dot has types dot just say key. Let's say we have first we need to take one key for the denom. So the key for denom will go to keys.go file. We need to initialize a denom key. So first of all, we need to set a prefix, like prefix for every key value pair, there is a prefix. So first we'll set a prefix for denom. Prefix for denom will be of 5 bytes. Just name it anything. This will be a hex value 0x01. Name it at first key. Then this key, we need to just make a key function for that, key denom ID function. So we'll have one more function. Let's name it key of denom ID. Key of denom ID. This will be of type string, and this will return bytes. Right. Yeah. First, we'll get the key. We'll append if already exists. Append on key denom that we just created here. Append and with some character. Let's name a character. Let's declare a character. Just a second. Let's create a character name. Anything. Let's say delimiter. Delimiter as equals to, right, just to have some space between these. We'll pass delimiter. And return key with the denom ID. Denom ID. For denom ID, yes. So we have to declare ID here, sir. So it will be of type ID. So I declared a key denom. Now in the has key, just a minute. Yeah, in the has key function, we can call types dot key denom ID and pass the ID. So we'll check if that key KV store has an ID or not. We'll just copy. We'll replace, just a second. Replace NFT types. Yeah. So first we'll check if the denom ID already exists or not. The first one is ready. So we'll go back to our function of create denom, and we'll call k dot if k dot has denom ID. We'll pass the context here and the ID. If it exists, then throw an error. Otherwise, return. So it'll throw an SDK error. It's just take an existing error. Just throw an error that denom ID already exists. So just take an SDK error, we need to import it. Just import the existing SDK errors. So you can see our first validation with respect to denom ID is ready. So it will go to create denom. So first of all, the code structure will be here we'll be calling the create denom part. So the create denom will have has denom. First check will be of has denom ID. It will go and call the KV store, and it will check if the KV store has an associated value with respect to ID of or not. And then we'll check, and if it returns it has a value, then we'll print out, then the denom has already exists, otherwise we'll move to the next check. So similarly, we can have a check for symbol, denom also. So let's set up a check for symbol also. So let's go back to the denom.go file. We'll set up a function here for keeper, and keeper, let's name it as denom symbol or not. So this will also take context as SDK dot context, and then we'll pass symbol. Symbol will be of type string, and also this will also return a boolean value. And first we'll check that the symbol length is, if the symbol length is 0, we'll return false. First we'll check the length of the symbol, because obviously the length of the symbol should be greater than 0. So if it is equal to 0, then we'll return false. Next check is not necessary, then we'll call the KV store, STO store. Let's call the KV store from context, KV store, and then we'll pass the KV store key, k dot store key, and we'll return if store has types dot key. Let's declare one more for key. Let's declare symbol. First of all, we'll declare another key with name as prefix. Let's remove denom. Denom symbol. Symbol will be of type bytes also. Bytes. Let's name dx as 0x02. So our key denom is ready. Now we'll write a function for that. Function is key denom symbol. Yeah, key denom symbol will pass symbol of type string, and it will return bytes. We'll get the key similarly as we did for previous one. We'll append it to previous prefix key symbol and delimiter, and return key, then byte of symbol. Yeah, so our function for key denom symbol is ready. We'll go back here, types dot key denom symbol will pass symbol. Yes, and our hash denom symbol function is also ready. Now we'll go back again to here, keeper, and similar to that we call k dot hash denom symbol will pass context, and symbol, and if we have already a symbol registered, then we'll return an error. Let's copy the error, SDK error. Otherwise, it will go to the next step. Next step, let's if everything goes well, let's call the set method for the set denom. So what I'll do, first of all, need to set the denom. So first we'll go to the denom and write a function for set denom. Keeper set denom. Context will be of SDK dot context. Will pass denom. Entire thing will be of types dot denom. This will be of type denom, and will throw an error. If error it is returns, we'll call a store key. Store call store key from context kv store k dot store key. And then will first step will be to unmarshal it. So sorry, to marshal it. So let's call another variable k dot context dot must marshal. Must marshal will pass to denom, and then we'll set. So dot call the set method. With the types, let's declare for denom ID. We have already declared, yes. For denom ID, we have declared denom dot with the denom ID. We need to just set the key in entire data. We'll set the entire data with the particular denom ID. So this is easy. And yes, let's check for the symbol because we have already passed the symbol. Let's check the length of the denom dot symbol is greater than 0 or not. If greater than 0, because symbol, if you have passed symbol, then the symbol should be greater than 0. Then in the store dot set will set types dot key denom symbol with the key denom dot symbol. So basically this check we have already mentioned it here, but for the safer side we are mentioning that symbol should be greater because we need to check the symbol, like we need to set the symbol because this symbols has been already set for this, so that for the next time if the user initiate a transaction with the same symbol, will throw an error. This has symbol as denom symbol. So in this KV store we need to store this byte with dot ID. So yes, everything goes well, then we'll return nil, no error. So set denom function is also ready for us. So we'll go back to keeper.go. Next thing we are returning error, right? So error will call k dot set denom, and then we'll pass context, then types dot new denom. New denom we have already declared here in the denom.go yesterday. So we can see type dot denom and we are passing everything. ID, symbol, name, schema, name, symbols, ID, schema, then creator, description, review URI. So yes, these things will be passed and it will throw if error is not equal to nil, then what we'll do, we'll return error and then we'll return error. And yes, and one more thing we need to set is the owner, like we need to set the denominator. So we'll write another function for denom creator. So we'll go back to the denom function and we'll write another function for, let's take this as keeper. Let's name it as function set denom owner, that collection owner basically. Collection owner will pass context will be of type sdk dot context. Yeah, sdk dot context denom id. Yes, the both will be of type string and owner will be of type sdk dot account address. Yes, and I will get the store key. Store will take the store from kv store with the particular store key, and then we'll let let's name it same variable as we did previously. Must marshal denom id. Yeah, must marshal denom id. So these are all the methods related to this I have declared in the codec. So must marshal to marshalling of the denom ID and marshal of the denom ID. All these methods are registered in the codec, another file. So that will be useful methods. So now this denom ID will pass k dot codec and then denom ID, and will set store dot set with the types denom create. Let's name another type called denom creator. So we'll go back to the keys.go with the same. We'll initialize one more key called creator. Prefix creator. So prefix creator will be of type bytes. Let's name 0x3. Yes, prefix creator is ready. Now we'll add the function for the same. Let's name it as so key denom creator. Key denom creator. Let's take an address as sdk dot account address. We need that with that particular denom id. Denom id will be of type string, and we'll return an error, or no, we have to return bytes because this is a key store function. Why does it throws an error? Just a second. Yeah. I'll get the key. Similar to that, our previous example, prefix of creator will under delimiter, and if first of all, first check will be if address is not equal to nil, then we need to proceed with it. Let's do key is equal to append with the particular key. Let's append bytes of address. And key, we need to append the delimiter to. Next check will be if address is not equal to nil and and length of denom ID should be greater than 0. These are basic checks. Then we can go forward with the KV store addition. Append the particular key. It's let's do is that copy this paste it here, other pass it denom ID. If all goes well, then we need to return the key. So yeah, our create denom is also ready. Types dot denom creator will pass what we are passing. We are putting owner here, right? Owner is an account address, and we are passing owner denom ID. We are passing denom ID here, and the third is yes PC. This variable we need to pass it here. So yeah, set denom owner is also being set. So let's call the denom owner here without set denom owner for the context, give the ID and creator. After that, return null. So our basic function for this store is ready. Now we'll go back to the message server. In the message server where we left, we'll just call the create denom function that all those KV store additions are being made. We'll call because it returns an error. This is the m variable m dot keeper dot create denom will pass context and everything message from message dot id message dot message dot symbol message dot name message dot schema. Yes, then we directly pass the sender and description. Next is preview URI, right? Message dot preview URI. So this is the last. Error will be not equal to nil. Then return nil, or if error is thrown in this create denom step, then we'll return an error. Otherwise, we'll go ahead and return the response and next. So yes, so basic our entire step of KV store addition for collection is ready. So as we discussed, after the type declaration, after the user initiate the transaction, it goes to the types where all the necessary checks being made. And after the checks are passed, then it goes to the create denom function. So how it goes will come back in the other section. We'll have to declare these things in the handler. So that's why then it will be passed to the message server. So right now it's from the message server. It will go to the basic KV store where all the checks related to the KV store are being made. These are checks related to KV store, and in the types are basic checks related to types and basic types. So in this we check the denom actually exists or not. the symbol actually exists or not. If all goes well, then we need to set the denom, like set the collection in the KV store. So these checks are being made, and the KV store are being initialized here in the keeper files. In the keeper files, where we have all the KV stores registered. Similar to the create denom, we can have our KV store registered for update denom or transfer or create NFT. Similarly, we can have our KV store registered in the keeper files and the message server registered in the message server files. So I guess this is up for today, guys.